A very natural place to begin with your STEP preparation is thinking about prerequisite background knowledge. In particular, although the STEP specification is designed with close reference to the A-level maths and further maths curricula, the overlap is not perfect, and this issue is compounded by the fact that almost all exam boards for further maths involve an option choice. In this video, we're going to focus on the case of the AQA exam board and go through the missing background knowledge which students following AQA Maths and further maths may have. In the case of students who have the choice about the optional modules they will take, we'll also think about the most STEP-friendly choices. We will be releasing similar videos for the other major A-level exam boards and also IB. Now, in many cases, students won't have the choice as to which modules they'll take because it will be predetermined by the school. And even if you do have the choice, there's no selection which will provide 100% coverage of the STEP specification. I would strongly advise that students, especially those taking Step 3, should learn the extra bits of material, for example, by making reference to an A-level further maths textbook. You don't need to cover the entirety of the options that you didn't select, only the bits relevant for STEP. Not only will this give you a broader range of questions to choose from in the exam, but as a general rule, questions on the more advanced material tend to be slightly easier as far as the problem solving is concerned. Now, it's really important to make sure you know what the background material is for STEP, partly because it will fill you with a lot more confidence, but it's also important not to obsess about this too much. It's not in the spirit of STEP to find a sort of very niche wrinkle of the specification and set a problem probing you on memorized knowledge. This is much more problem-solving oriented as an exam. So do take background knowledge seriously, but don't obsess over it too much. And finally, do remember that aside from material you're meant to be familiar with, one of the main differences from A-level is that in STEP there is no formula booklet. So all of the formulae that you're expected to know, you actually need to memorize, not just be aware that you can look it up in a formula book. The compulsory content for AQA Further Maths is all pure maths, and you then choose one of further mechanics, further statistics, or discrete. We'll assess the relative merits of each choice later, but in short, discrete is completely useless for STEP, and if you have any choice, should be avoided. Among the others, I would advise mechanics over statistics, because in the statistics, you do a lot more material that actually isn't relevant for STEP. Whereas what you do in mechanics is almost 100% relevant, and a lot of it is in fact Step 2, not even Step 3 material. As far as pure maths is concerned, the AQA exam board doesn't relegate any material to optional modules, and so there should be no substantial knowledge gaps. It is of course worth remembering that like any admissions test, STEP will have lots of ideas that are not part of the official prerequisite syllabus, sort of assumed prior knowledge, but which will nonetheless recur repeatedly between past papers. And we're not going to concern ourselves in this video with this sort of shadow syllabus, only the prerequisite background knowledge. Now, there are some small discrepancies between the AQA Pure Maths and STEP Pure Maths. So in particular, for Step 2, one example is necessary and sufficient conditions, or an equivalent formulation of the same idea, if and only if. So if you've prepared for TMUA, you will already have covered these ideas to a more than adequate level. And if you haven't, a good place to begin would be the Cambridge notes on logic and proof, which were prepared for TMUA. Another knowledge gap may be the remainder theorem, which is really just a simple generalization of the factor theorem. To some extent, you almost don't need to know the remainder theorem because you can in fact derive it from the factor theorem, and a good exercise is to convince yourself that you can do that. Another possible knowledge gap for Step 2 is the body of circle theorems that are covered in GCSE. So although you should certainly have seen these before, you may not have reviewed them recently. They can come up from time to time, including in mechanics, where you may need to get into the nitty-gritty of the geometry of a physical setup. Other knowledge gaps, sometimes on STEP they'll require the basics of permutations and combinations, including on Step 2, although in most cases students who've prepared seriously for a Cambridge interview will have had some exposure to these ideas anyway. There's also the change of base formula for logarithms, although like the remainder theorem, it's really something that you could figure out on your own, and again it's a good exercise to convince yourself that you could do it. And then there's a couple of other things for step 2 that in principle could come up, but in practice are quite unlikely. So in terms of the relationship between roots and coefficients of polynomials, in the A level, they can only go up to quartic. In principle, they could go to higher degree in step, although it would be very unusual for them to do so, and it really is just the obvious generalization. And they could also set partial fractions problems where a linear root appears with a power of more than 2. So you can have a linear root squared in A level. In principle, they could cube a linear root. Now, there are also some extra knowledge gaps that apply for step 3, but not step 2. One of which is solving polynomials with complex coefficients, although there's not really any theory to learn here, other than the fact that the roots no longer need to come in complex conjugate pairs. And finally, the method of solving differential equations by substitution, although in step, the substitution is almost certain to be given to you. As far as mechanics is concerned, if you're taking the optional Further Maths Mechanics module, you will essentially have no knowledge gaps at all, with a couple of very small exceptions which we'll enumerate here. If you don't take optional mechanics, you will have really substantial knowledge gaps, even in step 2. In terms of the gaps that you may have even if you do take further mechanics, in step 2 there is the idea of a triangle of forces for 3 forces in equilibrium. This is nothing other than the observation that if you take essentially the force arrows as vectors for all of the 3 forces, and you join them nose to tail, they have to form a closed triangle in equilibrium. And you can sometimes use this geometric insight to your advantage. As far as step 3 material is concerned, there are some more advanced differential equations ideas for variable forces, including the fact that you can write acceleration as v dv dx. This is nothing more than a simple consequence of the chain rule. And finally, there is simple harmonic motion as an approximation for a pendulum. So actually, simple harmonic motion as a topic, weirdly, is covered under the core pure for AQA, but this single application will not feature. Now, if you don't take the optional mechanics, first of all, in step 2, you'll be missing ideas to do with more challenging moments problems, including forces which are going at a funny angle, and where you need to use more advanced ideas such as inferring the centre of mass of a uniform lamina by symmetry. In rigid bodies problems, you'll also be missing the idea of how to analyse for sliding versus toppling at the breaking of equilibrium. Ideas to do with work, energy and power, including conservation of energy as a technique for problem solving, although this may be familiar to some extent from physics. There's also one-dimensional collisions, the use of conservation of momentum to solve physics problems, and also the idea of a coefficient of restitution. In terms of elasticity, you will cover Hooke's law as part of pure when you analyse simple harmonic motion, but the formula for elastic potential energy would not be covered. There are then some further knowledge gaps which apply for step 3 only, so oblique and more advanced collisions, including more sophisticated uses of the idea of impulse, more sophisticated centre of mass computations, including those which require the use of integration. Let me pause at this point, because I forgot to say one of the most important parts of the mechanics step 3 specification, circular motion. There's a lot of material to learn here, and you'll cover none of it without the further mathematics module. And although on most exam boards simple harmonic motion would be a gap, in this case that's not actually going to be the case because it is covered in pure. Students who take the optional further statistics module in AQA Further Maths will have essentially no knowledge gaps, and the small amount of missing material is very easy to cover. If you don't take the further stats, there will be some more substantial knowledge gaps for both step 2 and step 3, although as a rule these knowledge gaps are smaller and easier to plug than the corresponding gaps for mechanics. So regardless of the modules you take, there will be some bits of extra material you need to cover, in particular the inclusion-exclusion principle as applied to probabilities, the use of combinatorial arguments to calculate probabilities, usually in the context of equally likely outcomes, the conversion of a normal distribution to a standard normal distribution through the use of translation and scaling, and also the use of the Poisson distribution as an approximation to the binomial distribution, and the use of the normal distribution as an approximation to the Poisson distribution. If you're not taking the further statistics in A-level further maths, you will also need to cover discrete uniform distributions, including with a little bit more intuition for what a discrete random variable is more broadly, random variables more broadly, the calculation of expectations and variances and so on. So random variables are touched on in the compulsory single math statistics, but not really to the same level. There's also the Poisson distribution, including the derivation of its mean and its variance, and the mathematics of continuous random variables, including the probability density function, the cumulative density function, and the calculations of expectations, medians, and modes. There are further knowledge gaps that you'll need to plug for step 3, in particular the algebra of expectation and variance, the expectation of a function of a random variable, so the expectation of g of x for some function g and random variable x, and also the idea that for continuous random variables, you can use the CDF to work out the PDF of a related random variable. Now, it must be emphasised that much of the A-level further statistics material on things like inference, chi-squared tests, confidence intervals, the t-distribution, is actually completely irrelevant for STEP. It's not even on the specification. And this is another reason why, if you do have a choice, the statistics option may not be the best one to take, because you will be spending a lot of time on content that actually doesn't have any applicability to STEP at all. It must be stressed that in this video, we focus on the potential gaps in your knowledge. The vast majority of the STEP specification forms part of the core compulsory material on AQA, A-level maths and further maths, and so these small discrepancies don't need to form a source of stress. But it is a good idea, if you have time, to try to cover the extra material to broaden your range of question choice and capitalise on potentially easier problems. If you do have a choice of module for your A-level further maths, I'd advise definitely avoiding discrete, since it has no relevance to STEP whatsoever, and although it can be a personal choice, I would lean more towards choosing mechanics over statistics, because there's more material that you would otherwise need to cover separately, and a lot of the material you'll be doing on the statistics is actually, from a STEP perspective, a waste of time. Don't let your decision be skewed by preconceptions about which modules you're more likely to actually use in STEP. For example, students who prefer mechanics at A-level quite often find that in practice, when it comes to STEP, they find the statistics problems easier. So I would keep an open mind until you have experience working on STEP problems. Do also note that when you look at older papers, especially those prior to 2019, you may see some other ideas like covariance, moments of inertia, probability and moment generating functions, which are not part of the STEP specification anymore, and these questions can be safely ignored. If you do have extra material to cover, a natural starting point is the A-level textbook for the optional further maths modules. And if you're interested in more intensive support with your STEP preparation, we do also run a STEP preparation program at Vantage, in which all knowledge gaps are plugged from scratch. If you'd like to learn more about that, you're very welcome to visit our website. And thanks very much for watching.